Thank you for joining me. I'm going to be looking at question 10. This is fencing is to be used to construct an enclosed rectangular region. The area of the region is to, let's say, makes the fencing, and the fenced area is rectangular. The area is 8,000 square meters. Fence costs $16 per meter. On three sides, okay, so on three sides, and the cost is $24 per meter on the fourth side. Now that's interesting. Find the dimensions of the rectangle that will maintain the cost of fencing, that will minimize the cost. Well, if we want to minimize the cost, we need a formula for cost. And once we've got the cost, we can then derive that cost with respect to whatever our variable is. Let it equal to 0 and solve it. So let's follow that process. What is the cost? Well, let's make three sides. Side is y. Now, the thing is, we don't know which side is going to be. I would imagine that the short side would be the $24. So anyway, let's make x the 24, and we say the cost will be 2y's plus 1x. That is multiplied by 16. And that x on there is going to be multiplied by 24. That's the cost. Now, we've got two variables in here. So what we've got to do is use the other piece of information to substitute out. And we're told that the area is 8,000, which means xy is 8,000. So since the x is just on its own, let's say what x is, 8,000 over y. So let's replace that x with 8,000 over y. Cost is 16. We've got x in two places. All right, let's just replace the y. All right, so we've got 2 times y plus x plus 24x, $24 for each of those x there, and $16 for the sum of those three there. We're going to replace that y with 8,000 over x. We can cancel, no, we can't. Okay, so we've got 16 times 16,000 over x plus 24x. So 16 times 16, 256,000 plus 16x plus 24x. And so we've got 256,000 x to the negative 1 plus 3040x. Now we can derive that. dc dx equals negative 256,000 x to the negative 2 plus 40. Let that equal to 0. We're up to this step here. And I'll take the positive across to be negative. The negative across to be positive, sorry. And that x to the negative 2 is actually, I'll rewrite it to be x squared. Now we bring that x squared up to multiply with the 40. Take that 40 across to be divided underneath 256,000 divide 40. 4 goes into 256. 4 sixes are 24, 64 times, and then there's another 2 zeros. Get the square root. X is the square root. We won't use the negative of 6400, so that's 80. We found, is it meters? 80 meters. We found an X. Now we want to find out it's optimized, so we want to put that into the second derivative. So d2c dx squared is positive 256,000 times 2 x to the negative 3. So if we put 80 in here, we get 512,000 over x cubed, 80 cubed. We get a positive number. Therefore, it is a minimum at x equals 80 meters, which is what we want. What's the question ask? Find the dimensions that will minimize the cost and find the cost. Okay, so we want x and y. So if x is 80 meters, then y is 8,000 over 80. Right, there's y over x. So we've got 100 meters. So we've got our length. And now we want the cost. The cost will be 16 times 2 of those and 1 of those, and 24 times x. And there it is. That's the cost. 280, 16 times 280, 24 times 80. Put that into the calculator. And we've got 16 times 280, 4,480, 24 times 80, 1920, and we've got $6,400. That's the cost. I hope this has helped. Until next time. Stay happy.